Day 6. The sea floor is getting steeper. Maybe the Slakeys got carried this way. The massive school of glowing lanternfish. These are lanternfish. Swims past. They must spawn quickly to reach such large numbers, maybe exponentially quickly. You should model their growth rate to be sure. Although you know nothing about this specific species of lanternfish, you make some guesses about their attributes. Surely each lanternfish creates a new lanternfish once every 7 days. However, this process isn't necessarily synchronized between every lanternfish. One lanternfish might have 2 days left until it creates another lanternfish, while another might have 4. So you can model each fish as a single number that represents the number of days until it creates a new lanternfish. So each lanternfish is basically a timer. Cyclic timer. Furthermore, you reason a new lanternfish would surely need slightly longer before it's capable of producing more lanternfish. 2 more days for its first cycle. So suppose you have a lanternfish with an internal timer of 3. Then it goes to 2. Then it goes to 1. Then it goes to 0. After another day, its internal timer will reset to 6. It would create a new lanternfish with an internal timer of 8. Okay. The lanternfish that creates a new fish resets its timer to 6, not 7, because 0 is included as a valid timer value. The new lanternfish starts with an internal timer of 8. Okay. Alright. This list means that the first fish has an internal timer of 3, the second fish is... Alright. These will grow exponentially, so I don't think we should store it like this, but instead store a count of how many of each internal value we have. Because that means we'll have at most 9 values, rather than a list of exponentially growing values. I'm guessing this works for part 1, if we do it the slow way, but I'm not going to. Well, that's already a lot of fish. So we do have to be efficient here. Okay. So let's say counter. fish equals counter. Then we're going to count using just put this one here. So we take the line, strip it, split it on the comma, cast it to ints, and then just make it into a counter. So what it should look like is that. That's how many we have with that. That's how many we have with that, and so on. Okay, good. So what was the question? After 80 days. All right. So for day in range 80. So basically we want a new counter equals just an empty counter. So we want to say for timer count in fish dot. So basically we're just looking through the counts and the corresponding internal timer value. So if timer is 0, then this is where we create new fish. So first we will just, all these fish will just reset. New counter. And they reset to six, but a new fish starts with 8, so it's going to be new counter 6. Let's see, equal count and new counter 8 plus equal count. They each produce one more fish. Else we just count down, so it'll be new counter timer -1 plus equal count. So we've got this new counter, and I think we just want to replace fish with the new counter. So now we have the new population of fish. And after 80 days, just see what it looks like. Look at those numbers. That's why you need a counter. I mean, you could still do it in one massive list, as is implied in the on the site, but it'll probably take a long time and you'll have a lot of values, and part 2 is probably going to ask in the millions or something, in which case it just won't work. So what was the question? How many lantern fish would there be total? Okay. Print sum of fish.values. Hopefully we don't get an off by one error if I've not done the right number of days or something. Like day 0, so it's 80 days after the starting point, right? So correct. Okay, good. Suppose the lanternfish live forever and have unlimited food and space. Would they take over the entire ocean? After 256 days in the example above, there would be a total of that many lanternfish. How many lanternfish would there be after 256 days? So I think because we've done it as a counter, it would never grow exponentially. The numbers will get bigger, but we'll only ever have 9 values in the count in the counter. So this should be straightforward. This is probably the first problem where you have to do something a little bit smart. But I think we could just change that to 256 and it should be fine. There we go. Instant. Correct. Nice. That was a good problem. That's where you have to be at least a bit smart about how you're handling the data. The previous problems are mostly you're just sort of coding things as they give you. Pretty much exactly as they spell it out. But this was the first time you had to not do that. Because if you did that, for 256 values, you'd have that many values in the list, and you'd probably run out of memory. Yep, that's a good problem. I like that one.